Hello, good afternoon, good morning, and good evening for those who have joined us from other time zones. My name is Tat Baki. I'm with the product management team of Calibrate Systems, and today I will be your moderator. And let me welcome you to this webinar entitled Advanced Analytics for Power Generation. However, let me be clear that what you'll be hearing today is not just exclusively for power generation companies, as what we will be discussing and presenting to you today is applicable to other industries such as oil and gas, process manufacturing, transmission and distribution, and the likes. All of the industries that can be covered by the solution that the Visplore, our partner, has in play. So in the next 45 minutes, we hope or we aim to give you valuable insights on how we can reduce, lessen downtimes with the use of tools like self-service advanced analytics and help you to troubleshoot quicker so that you are able to address whatever issues, the day-to-day issues that you may be facing in your respective facilities. So we have two presenters for today. We'll have a Q&A session and most importantly, a call to action where we can have further discussions on how we can help you with your respective needs. So without, oh, one thing I forgot to say is that for the Q&A session, you will see that there's a Q&A box. So please do put your questions there and we'll try to answer all of them during the session itself. So without much delay, I would like to call on the first speaker, Mr. David Lim of Calibrate Systems. David?
Hi, thank you, Tat, and good afternoon to everybody. So I see some familiar names. I just want to say hi to our customers, and I'll just give a brief introduction or updates from the Calibrate side before I turn over to Thomas to discuss further about Visplore. So let me just share my screen. Yes, so again, good afternoon. So just a quick update on Calibrate. So as you know, we are headquarters here in the Philippines. We now have an office in Malaysia, Singapore, and just late last year, we opened up our US office. So AVEVA, we are in partnership with AVEVA and Visplore, but for AVEVA, we are very fortunate that they awarded us Partner of the Year globally for the last 2 years. And with Visplore, we're actually working together with in TNB, with Delaga Nacional on their grid division. Um, for us, so how do we help our customers? We help you guys in your digital journey. We can connect to over 600 interfaces on the OT side. We aggregate that data into a central repository, which is the PI system. Now we could start actually in the data analysis. For Calibrate, we have provided templates for asset monitoring, for actually more process efficiency. But what we are in partnership with Visplore right now is towards on the right side, more on the advanced analytics. And also, actually, what we like about Visplore is that it's an on-premise solution and it can be on a per use case. Like Tat mentioned, it is a self-service advanced analytics tool. We like that because analytics should not be a big project. It should be able to address your requirements very quickly, and Thomas will provide more insights on that one. And of course, as Calibrate, as a system integrator, we can provide you solutions or help you in your cybersecurity as we now get more data outside the plant and facilities. So just to share, on the left side, Calibrate can help you in integrating all your automation and control systems, any sensors as mentioned. But on the right, this is where the exciting part comes in because Visplore is here to help us and actually not just on data analytics, but on how we can actually gain more insights as mentioned in their as we do data exploration. So again, the value is really how to create this journey towards not just operational intelligence, but merging it with business intelligence. So I'd like to show you two videos just to update you on what we're doing. And also the last video is about our CSR. So I'll show you first just an update on how we put together the data from Pi into 3D version.
Hi, I'm Sam. In this video, I'm thrilled to show you how we brought a real substation to life in 3D and how we overlaid data from our Viva Pi historian to create a true digital twin. First, we spent one afternoon capturing every angle of the substation. We used a 360-degree camera for panoramic shots, a standard phone camera for close-ups, and a drone for those sweeping aerial views. Next, we handed these photo assets to a freelance 3D artist who worked part time for a month and a few days to transform them into detailed, accurate 3D models. Once the models were ready, we spent another month integrating them into a virtual environment built on Unity. We linked it all to our AVEVA Pi historian so we could see critical substation data like transformer temperatures, circuit breaker statuses, and more inside this immersive simulation. The result? A fully interactive digital twin that not only looks authentic but also provides actionable insights to help us keep our power grid running safely and efficiently. Come take a closer look and let's explore how technology meets reality in this cutting edge substation experience. Thank you.
So just showing you the glimpse of how we are doing it, and we're doing it with simple tools. And I wanted to show you another video. This is very close to our hearts because this is in partnership with ABS-CBN. We encourage volunteers to join us because, again, the goal is about saving our environment for future generations. So I'd just like, again, to share what we have been doing with data. So, guys, thank you very much. Again, I'd like to introduce Thomas, CTO of Visplore. So, Thomas, I now give you the floor.
Thank you very much, David. So sharing my screen now. Hoping it's visible nicely. All right. So, hi, good morning and good afternoon from my side. I'm Thomas, CTO of Visplore. So at Visplore, for many years, we've been providing advanced self-service analytics for power generation and beyond. Now, why do you need self-service analytics? Let me give you a short motivation. Because digital transformation as a whole is a major investment, right? So you have a lot of costs for things like data acquisition infrastructure, installing all of the sensors, the infrastructure to transmit this to your data management software and historians, for example, AVEVA PI system and other data sources. Acquiring data talents, so persons who have the background in the process and operation, but also are savvy to analyze that data, as well as cybersecurity. All of these, of course, are investments, and the return of investment can only be achieved if all of that data is actually used optimally. However, if you look at the status today, according to reports, a large part of the data, like 85% collected, goes unused, according to reports by Gartner. According to World Economic Forum reports, more than half of the workers in the companies still need upskilling towards more, let's say, operation and handling of data. And 89% are not achieving the desired digital transformation results yet. So there's also still a lot of room for improvement. And how can you change this now? Well, our mission to change this is by enabling the engineers to use the data more easily for their daily decision making, the subject matter experts, so to say. To avoid spending countless hours in spreadsheets for the data preparation, but actually focusing much more on creating the business value itself. To realize the full potential of your data and to have that return of invest from the digital transformation in the best possible way. And how exactly do we do this? With our software Visplore. Visplore is an end-to-end solution for data analytics in operation and maintenance. So a solution for what? What are the use cases? First and foremost, it's fast troubleshooting. Troubleshooting when something is wrong with your process. So you can connect to your existing data sources like AVEVA PI, plug and play, and explain asset failures of assets like boilers, bearing, valves, heat exchangers. So you can bring all the relevant together, all of the relevant data together in Visplore for the ad hoc troubleshooting. Next is automated advanced condition monitoring. So to make sure that the problems you identified are actually automatically detected very soon in the future. And advanced here means that it actually goes beyond, let's say, static thresholds, which you already have, I assume. But you can define, for example, a corridor for a plant startup graphically in Visplore. Then easy correlation of data sources. This means that you can import data from historians like Pi, but bring it together with things like event logs, even manual logs, for example. If you have like temperature measurements from the plant recorded in files or in tools from Calibrate, then you need to correlate such things with the Pi data, for example, which you can do directly in Visplore. You can also automate performance reports. So like you see on the right side here, for example, a report of the last 3 startups of your plant and some KPIs. And most importantly, all of this is actually made for subject matter experts without coding. So actually, it's meant to be very accessible for teams in operation and maintenance. Now, when you see pictures like this, you might wonder, why do we need this? We already have a dashboarding tool or a monitoring. So let me make one distinction in this direction quite clear up front. What's the difference here between real-time dashboarding tools that you might already have, like AVEVA PI Vision or others? They really focus on the current status of your operation. So what is just happening right now? Much like a traffic light, they tell you for visual monitoring based on short histories in time if everything with the process is as expected at the moment. However, analytics here are typically limited, like correlating variables to many other sensors or comparing them historically to how it should be from the reference. This is usually not the scope of dashboarding here. It's meant for what is happening right now. And on the other hand, self-service analytics like Visplore go much deeper in the direction of why did this happen? Why did the problem happen and how can we avoid it in the future? So it's much more diagnostic and exploratory in nature, where you bring together all the tags and information that you need to consider, and it's usually also based on longer histories, like comparing if startups of the plant right now, how do they compare to startups a year ago after the last maintenance? These are things that you need for troubleshooting, as well as advanced analytics of correlations and patterns, which is also needed to bring again together the relevant parts of operation, for example. And the most important aspect here is not that it's an either or, but actually both are needed for efficient operation and maintenance. You need to know what is going on and why. All right, here you see a selection of companies globally that are trusting Visplore and using it for their operations. So here you see on top power generation. Here are several companies from, let's say, operating gas turbines, combined cycle gas turbines, coal power plants, hydropower, and nuclear plants and others. And like Luminous, for example, in Belgium, in AVEVA in Germany. Here are several hydropower plants in the DACH area as well. But beyond power generation, we also have companies, for example, in transmission and other utilities. So here you see TNB, the national grid operator in Malaysia, but also Australia, Near and Middle East, South America. We have companies in these areas using Visplore for similar applications. And then also other industries beyond, let's say, electricity and utilities are using Visplore. For example, steel and other material processing, paper, vehicles, and more. Now here, maybe worth pointing out, we also have companies that are customers of Calibrate, as David mentioned before. Tenaga and POSCO, for example, are two companies here in that sense. And POSCO is a company that actually recently the collaboration started through our partnership with Calibrate. It's actually really nice. Okay, and what are these customers doing with Visplore? Today I want to share 3 use cases with you. And these use cases are about troubleshooting of assets and also about condition monitoring. So let's start with the first one. The first use case I want to talk about is from a combined cycle gas turbine. In such CCGT plants, one important asset are valves. So valves are an important control element for the flow of water, steam, and the amount that's flowing through a valve has to be as expected all the time. So if you take a look at this image in the bottom right here, you would see that for a certain recorded opening position of the valve, there is a certain corridor of expected flow rate. This is what you see in blue. This is usually also given or known for a valve from the vendors, for example. And if the valve is starting to be clogged or coming loose, then the flow may be too much or too little compared to what you would expect from the recorded valve position. And if such a thing like a clogging or a valve coming loose is not recognized early, it may lead to a major maintenance need. So in the use case that I'm going to show you now live in Visplore, imagine that the meter readings of the water flowing through, for example, afterwards showed an unexpectedly low flow. And now the engineers want to inspect what was going on here based on the data. Why is this flow too low? And for this, I'm going to jump over to the Visplore application. So Visplore is a software that can run on any Windows environment, like a user's laptop's desktop or a server. And very importantly, it runs on premise. And it connects to your existing data sources. So for example, you can import files from Excel, CSV, and so on. You can connect to databases, but you can also connect to historians like the AVEVA PI system. For this, we have a direct connector. And in the example with the valves now, the engineers want to load several months of data from PI to inspect it. So that means they can select now here which time period they want to import. This was something from last year in a certain time resolution, and you can select the tags from data archive or from Pi asset framework by searching or browsing the hierarchy. Here we have selected flow rate, water temperature, valve opening position, and water usage from this plant as 4 potentially relevant sensors. Then we import them to Visplore. This fetches the data from your Pi server. And now Visplore immediately shows you some graphics and statistics for the imported data. Okay, so it does not start with a blank canvas, but you already see some aspects of this data. So for example, you could select here which sensors you would like to see and can plot them down there if you want, and zoom and so on. And you also see some statistics. Now for our use case, we want to inspect the recorded valve opening and the flow rate. These are the two that should actually behave as expected. And they mostly correlate also, as you see down here. But for correlating two sensors, there is actually many more visualizations that you can use inside of Visplore. For example, a scatter plot. Okay, so this is an XY plot like we saw before, valve positioning on X, valve position and flow rate on Y. And here we already see that these two sensors mostly correlate as expected, but there is also some kind of drifting points down here. So this already confirms at first glance something was happening with this valve. And now, something very special about Visplore is that you can select data points in any of the visualizations. Like in a graphical drawing program, you just mark them up. And by marking up July here, you would immediately see this data also highlighted in the other visualizations. So like here, you would see in July, everything was still okay with the valve. And as I change this and move it a bit through the timeline, you immediately see how this updates the point cloud on the right side. Okay, so you could find out easily that way that here, October towards November, sometime here, this must have happened. The valve. Okay. So, but there is one better way to find out when and what exactly happened here. And that would be here in this scatter plot. I can actually, if I have one, I can add an image like the one that I showed before to add it as part of the plot. Then align it nicely because I have to tell for which data area is this image defined. So let's say this is 0 to 100% of valve opening, and this plot is defined from 0 to 2,200 liters of water flowing through. And now this image fits very nicely with the plot. And what does this tell us? It tells us that these points are indeed not according to the vendor specifications, but in this performance loss region down here. And now, to get to the bottom of this, I can also select these outlier points in this plot, using a lasso, for example. So just by a few clicks, I can draw a polygon here for this process operating state and have selected all of the underperforming points of this valve to see when exactly this happened. So maybe to make this clearer, let's not just show only the selected points, but all points. And now we see during these months, this underperformance has happened sporadically for one data measurement. But at some point here, let me zoom in. Actually, we see that at the 20th of October, these two sensors have started to drift apart. So right now here, something has to have happened with this valve. And what happened here at one of our customers is that in this point, actually, they looked at the maintenance logs of such an asset and see, yeah, here was, for example, the last maintenance. And when inspecting this valve, to discover that it was actually not left after the maintenance in the way that it should actually have been left. Okay, so this was something where a clogging was detected similarly also at one point at the customer. And the point here is that actually with just a few clicks in the plots, you can zoom into long areas of time, you can correlate the sensors, and you can graphically define the process conditions that matter to you. Okay, like filtering out, filtering and defining a certain condition like this non-correlation down here. This is very, very helpful for troubleshooting. But the next logical step would be to automate this in a way that you are always notified when this happens in the future. And this is possible with just a few more clicks. So after defining this polygon here, I can just say, create a condition that I want to track from this, and let's call it too little flow on valve V1, for example. To make this robust, we can tell that not every little point should be detected, but actually only if 1 hour or longer consecutively is actually in this process region. And we can tell that we want to receive an email when this condition happens. Okay. Now I could put some recipients here. Let me just put one inbox here that I have. And for the body, we can tell that in the email, the person already gets, for example, some instructions. Go check valve V1, too little coming through. You can also add some images to the email so that the persons can spot immediately if this is a false positive maybe or what's going on. So let's add the visualization of this scatter plot down here directly to the email as a JPEG image. Okay. And finally, what also helps the engineers that get such an email is to have a link to directly see this in Visplore. That we can also do here. We can add a link file that will be an attachment. So for example, if the image is not telling enough and you need to inspect some additional signals that are not shown in the image, open it in Visplore and go to the bottom of it. And with this, we can test what would happen if this happened right now on the data that we see in the past. What email will I get? And for this, I can open up Outlook to see. Second, here the email has appeared. And this is what the engineer or the operator would then see. Description, image, and the link up here to actually look at this in Visplore, that it opens up like here, and you can then do more root cause analysis and go to the bottom of what and why has happened here. It's very important for me to note that this aspect of troubleshooting and also of automating actually does not need any programming, okay? And you couldn't even easily program something like this process operating region here with this lasso. Even if you could do it in Python, it would not be easy. And so we focus really here on enabling the engineers for this end-to-end workflow from troubleshooting to actually automating things. And I can schedule this now at a certain interval that it runs, checks, and sends me these emails. All right. And let me jump back to the presentation and on to the second use case. So, in the second use case, this is an example from hydropower. It is from Hafslund in Norway, and we published this together last year at a conference. Now, this is about troubleshooting unusual heat in a bearing. Okay, so the field operators noticed after a startup of the turbine, they noticed this unusual heat developing. Every time they started up the turbine, you see the bearing temperature here. Actually, the temperature was rising and rising. And so to help them with the troubleshooting, the operators here contacted the machine specialists in the central office to help them do the troubleshoot based on data. And these engineers connected Visplore to the PI system, extracted all relevant turbine startups also from the history, and compared the incident to the history. I will show you in Visplore how this was done. And also, Visplore helped them identify correlating parameters that might explain what's going on for root cause analysis. And this I want to show you here in a short live video that I will tell the story to. All right. So the engineers started here by importing 8 months of data from their AVEVA PI system for 30 signals. Visplore immediately shows you the graphics and statistics, and in the bottom you see the bearing temperature. First some normal operation, followed by a long maintenance period in summer, and then here, after this, the incident happened where the temperature rose. So they wanted to compare the current operation to the historical reference and see what's different. Comparing time periods is very easy in Visplore, as you see. Now it's compared here using color. But now they want to focus only on the startups of the turbine, because this is when it happens in the incident. So you can select one example of a startup here and use a pattern search feature to extract all of the similar startups from the long time series and overlay them. So here in the top right, it still looks a bit similar in orange and the blue from the reference. Doesn't explain much, but if you add a bit of time context after every startup, seeing the 6 hours after every startup, then you see that actually the temperature does not stabilize during the incident, but it's really increasing and increasing, where usually it stabilizes at 70 degrees after 2 hours. So it's rising until the turbine is switched off again. That's a problem, proven on the historic data. But why do we have this problem? This root cause analysis is also done in Visplore, and this time they focus on the steady state, looking at the steady state before, so after this incident and before, to see what was actually also maybe suspicious during this overheating period. So again, selecting the steady state with a lasso and comparing the good to the bad period of operation. And now Visplore gives a list of all sensors ranked by how different they are before and during the incident. The bearing temperatures here have increased, but all other parts of this turbine around the bearing, like the coolers, have not heated up. The temperature has stayed the same or even gone down a bit. And this was an interesting insight for them, that actually Visplore showed them the only sensors that have changed are the bearing temperatures themselves. So they said, okay, it's not ambient conditions causing this. It's not parts like the coolers causing this. The problem has to be in the bearing itself, because only the bearing heats up. And this gave them the confidence to tell the field operators, please open up that bearing and look for physical damage. And this is what they did. They looked inside this bearing and found out that there was a punctured oil film in the bearing that actually led metal to be touching metal, which led to this heat up and actually damaged the bearing as well. And they also said that this was just in time discovered, a few more startups, and this would have been damaged to a point where actually the repair would have taken very, very long. So now they could schedule a repair for 3 weeks to exchange and repair that metal instead of 6 weeks in an even more expensive season of the year if they hadn't acted so fast in this case. And after the repair, the temperature was even lower. Very importantly, this was halving the downtime from 6 weeks to 3 weeks, which actually saved up to 1.1 million euro revenue loss compared to if this had happened later in winter. So very fast troubleshooting by combining the visualization and the analytics to guide the engineers to find out what's going on. Okay, and for the third use case, this is from a CCGT plant again. It is from Luminous, and this has also been published. And it is about detecting leakages in steam boilers. So leakages in steam boilers, they decrease the efficiency, and also they have to be detected before they grow, of course, because they also pose a risk for downtimes. And a usual way to detect such leakages is to look at the increased water consumption at this point, but that's rather late. And then to localize such a leak during a planned shutdown could be doable with sound tests and pressurized air, but this actually might prolong the downtime for up to days if you have to search for such a leak in there than with such things. And now Visplore helped the engineers to monitor the boiler locations for leaks without performing extra tests. And how do they do this? If you look at this picture here, you see they were looking at the rate of pressure drop during the shutdowns of the turbine. Okay, so when shutting down the turbine, that's a quite controlled time of operation. Looking only at these shutdowns, if the pressure is dropping then faster than usual, that's indicative of possible leak. And if you have multiple measurement locations of this in your boiler, then it can even tell you where does it drop the fastest, to give kind of a clue in which area you might have to build, let's say, a scaffolding or something for doing the sound test with the air quicker and faster. So it enables a better maintenance planning. And this way, an actual leak was detected in 2023. And to give you an idea how this looks like also in Visplore, I want to show you a short video here. So here you see some weeks of operation from this CCGT turbine. And here you see the temperature time series. You see clearly the startups and the shutdowns of this turbine. Now the extraction of the shutdowns is done in this video, again using the pattern search feature. Using the temperature curves here, this is very distinct even if you have a leak, selecting one shutdown and searching for it. Now you see all of these temperature gradients overlaid. They look quite similar and nothing suspicious about this yet. But then, looking at the pressure, looking at the pressure, actually, you would then see that here, some of these are dropping faster. And then all you have to graphically do is draw a corridor, for example, where this actually, if intersecting, is indicating a problem. So here you could give again a condition name fast drop if this pressure is dropping below 500 units in less than 3 hours. Yeah, simple as that, you can define such a complex thresholding here on a certain operating state. And this allows you then to schedule it again with email monitoring like I showed before, and to give you an idea how this can actually give the better maintenance planning that can save up to multiple days of downtime as well. So what you saw in these use cases is actually how Visplore supports this end-to-end workflow for engineers, right? From connecting to the live data sources like Pi, filtering out all the irrelevant parts, and graphically defining conditions and reports in there. These can be corridors, it can be lasso selections, it can be regression models, all of the things that you can graphically define here. And of course, you can also compute things in Visplore with formula editors, but you can do a lot of it graphically. Then you would automate these analyses and alerts to run for you. And when you got notified, you can enter the root cause analysis to find out what's going on, and also maintain all of these monitorings and reports by the engineers themselves. So it's actually a kind of cycle, that it's not a big IT project or a data science project every time to set up monitorings for assets that need to be monitored, but maybe wouldn't be the first ones you think of for a big monitoring project. One thing I want to point out is the suitability for your IT landscape. So Visplore connects plug and play to many different data sources like AVEVA, also Pi, but actually also many other databases, Wonderware, AVEVA Historian, data lakes, many file types, and we also have extendable APIs to connect also to sources not listed here. That could be custom file types, for example, for manual recordings, or it could be custom databases and so on. So we are flexible here to extend this also to additional data pipelines. And one important thing I want to mention now is, again, how is Visplore different from any other tools and self-service analytics solutions you might find out there? First, Visplore is easy to learn because it comes with these pre-configured cockpits and views that you saw before. You don't have to set up everything from scratch like you would do in spreadsheet tools, for example. You have the plots, many of them actually, to use right out of the box. Also, Visplore gives you usually a lot of unexpected insights by this very exploratory and interactive approach. So this fast data exploration of linking multiple visualizations and bringing in the data from many sources, this is actually quite unique, and there is no better tool than Visplore to focus really on this data exploration and ad hoc troubleshooting part of analysis. Also, reports can be generated very nicely because Visplore couples the business intelligence views like heat maps, bar charts, and so on with the process data visualization. So all of that you know maybe from Tableau or Power BI, this kind of analysis is also available inside Visplore to be linked with the raw data visualizations that you saw before. Also importantly, the sharing of results is possible in a free reader version that we have without additional costs. So you can define a data story, publish and share it with other departments, with management and customers, even without them having access to a Visplore license. Because this free reader, like with PDF reader, for example, can be downloaded from our homepage. Very importantly, Visplore's deployment actually focuses on on-prem, so there is no cloud-only policy. No data has to leave your premises. This is also very important that we support this. Finally, Visplore is very price competitive in the market here, so you can actually start small with Visplore with certain use cases, certain plants and so on, and then start with it actually very, very quickly. So here, this is kind of a summary of how Visplore is different. And to get to the end of my presentation part, I want to give you this quote here. Data is actually like electricity. It can light up your business and power your decisions if you have the right tools to enable this. Okay, with this, I want to thank you for listening also to my part of the presentation. We are very happy to answer your questions now in the Q&A part. For this also, my colleague and co-founder Harald, our CEO, will join us. And and for this, I also want to hand back quickly to end the screen share for this. You joined. Join me here, Harald. And then we can see if we have some nice questions from the audience.
Yes. Thank you very much.
Sure. All right.
That you
Let's
would
see.
like to have
Hello
that.
from my side. I'm Harold,
Yep.
CEO of Visplore.
Hello, hello, Harold. So I know there are more things that you would want to share during that presentation, but probably we'll have more chance to have that one-on-one discussions with the clients that we have here. I just went through the Q&A box, and actually the first question that I have seen is that is Visplore, is this just for data scientists?
Maybe let me answer this question. So Visplore is mainly designed for engineers who need data-backed decisions to take actions and who have no deep data science background. Yeah. So when looking at our customers, I'd say we have lots of maintenance and performance engineers among our users, but also process engineers, mechanical engineers, and quality engineers. Yeah. They use Visplore for their day-to-day troubleshooting, as we have seen in the demo, and it's also used for bigger projects. Yeah. That being said, we also do have data scientists among our users, and they like it a lot to speed up their projects. But as I said before, and I think that's important, a data science background is not necessary to use Visplore.
Okay. Thank you, Harold. And another that I've seen actually was asked. So let me just read the question. So how do calibrated systems and Visplore contribute to the success of power companies by leveraging PI system, data integration, and digital twin technologies to optimize power gen operations and ensure reliable energy delivery?
Maybe I'd like to take a crack at that one, Thomas, Harold. So one is we partner with our clients. We have to sit down with you really on how to start that journey into that operational excellence and to how to really help you. First is really gathering the necessary data. We need to really get through the true source of the data because real-time data is very important. Then again, going to that journey, how we can now put it in a single repository and push it to Visplore for more advanced analytics. It's an end-to-end solution and partnership with the customer that we would like to really start with you. That's my take on it. We can drill down later on, or I can talk to the client offline. But I think more importantly is the collaboration with the clients.
Thank you, David. Would you like to add something to that, Thomas, Harold?
I think it's the best starting situation if you have the data integration ready to start, because that's usually the first question that people ask: how do I get my data in? I think with Calibrate we have a very good starting point here to actually connect to sources like AVEVA PI directly, and also, for example, manual entry tools and so on that also Calibrate would then provide, bringing this data together and then leverage really a lot of value from things like troubleshooting, monitoring, and so on. Yeah.
So in the end, it's about things like less downtime, less work hours spent on data preparation, on preparation of reports. I think that's the concrete benefits that companies get out from this. Yeah.
Yep. And essentially, you're saying that you can do it faster because, I mean, there's not
Yes.
much preparation that is needed. Good. Good. One other question is that how can the system tell you the root cause, for example, of an anomaly event?
Yeah. I mean, maybe I take this. Let me say that really identifying something as a root cause is always in combination with the engineers working on this. Yeah. So what Visplore actually does, it still takes a data-driven approach. Yeah. So this means it's in the end it's based on patterns, statistics, and so on. Yeah. So it will show you correlations. It will not show you causations, to distinguish what is really a root cause, from a, let's say, mechanical point of view. This is up for the engineers to decide, which we actually consider as strengths. But what we emphasize all of the time is that Visplore brings transparency, and involves the knowledge, the deep knowledge of the engineers about their specific assets and processes in that. Yeah. But what Visplore does to make this very fast is it provides advanced analytics, that, for example, immediately identify which sensors have changed, which combinations of sensors have changed. If you look, we have seen this valve example before. It was not just a single sensor changing the level, but actually two sensors changing together, so that we have basically got into an underperformance region. I mean, if you have 3 sensors, this is easy to figure out, but if you have hundreds or thousands of sensors, it's nearly impossible to figure that out by hand. And this is where Visplore comes in. Visplore does this analytics for you, and suggests the plots where engineers can just go down and say, okay, click at this, ranked by their relevance, to immediately see, okay, hey, these are 2 sensors that changed in a way that was actually unexpected. And so this troubleshooting task becomes a matter of, let's say, a few minutes, in some extreme cases, maybe a few seconds, where otherwise you would have investigated, I don't know, days or weeks, to kind of search for the needle in the haystack.
Like that,
Now,
maybe if
yep,
I
go ahead,
could
sir.
add something to that one. Like I mentioned earlier on the first question, collaboration is key. Because in what we did with our customers before, our analysts sit down with them, they create this trip logic based on the assets, own manuals. Because on that trip logic, we can now really see on which parameters are actually being abnormal or has an abnormal pattern. It's not just the end result that it's tripping, but once we actually lay down all the trip logics, that's where we start going deeper and deeper to the real source of that abnormal pattern or anomaly event. So again, it's a collaboration. That's where I'm pointing at. Thank you.
Thank you very much, David and Harold. One other question is that how different is Visplore from an asset performance management system?
Well, I would say on the one hand, a very, very distinctive aspect that distinguishes Visplore from other asset performance management systems would be, let's say, that the interactivity and the involvement of the engineers to really transparently see what's going on under the hood. So, for example, it's not just about monitoring the performance in terms of some KPIs that you see, but you can actually immediately dive into this kind of underlying root cause analysis and getting a higher level of insight of actually what is causing the different things, to building that know-how, that especially also this troubleshooting part, I would say, is a very unique approach to involving the engineers to do this very quickly. So I would say the way that they can graphically define complex conditions, if you talk about the monitoring part now, that the engineers can define complex, like this relationship of the valve and so on, graphically, and not needing to make, let's say, a big project out of this, I would see is also a unique way how we address this performance monitoring aspect in Visplore differently.
Okay, good. Oh, okay. This one question I think is typically asked, especially on it's more on data security. So how does Visplore ensure data security especially having companies with strict privacy requirements. So how does Visplore do that?
It's a good question. Yeah, thank you. So actually, again, it's very important to point out that Visplore supports fully on-premise installations here as well. Yeah, so no data actually goes to the cloud with Visplore, and it also accesses the data right where it is from your existing data sources like Pi databases, files, etc. Okay, so it means that there is actually no duplication of the data needed somewhere else, especially not outside of your network. And also the communication, of course, between Visplore client and server and so on in your network is encrypted. Maybe this also answers another question here that I see, that is Visplore an app that's installed on all client machines to do the monitoring? Actually, it has a client and a server part. Both are in your network, on your premise, okay? The clients are the user interfaces that you've seen, and the server in the background is centralized to run your automatic jobs. And therefore, this is also the architecture that's that you would expect here. But actually, nothing has to leave your premises, and that's important, I guess, for your security aspect here as well.
Yeah,
that is why.
And maybe adding to this questions about does it have to be installed on all client machines? No, it can also be installed on a central Windows server. Yeah, so
also the user interface part.
Also the user interface. I think that's important to add here. Yeah.
Thanks.
Okay, good. Oh, we actually have several more questions, but I think we have time for just one more. There's this question about there was mention about data exploration. I mean, what is it, and is it relevant to me?
Okay, yeah, maybe I take this one. So in a nutshell, data exploration means learning new things about your operations from your data. Yeah. And often this is unexpected things. Yeah. So maybe to put this a bit in contrast to the usual way that people are, let's say, familiar with of looking at data in dashboards and reports. Yeah. That's not about data exploration. Why? Because data exploration is not about getting the same standardized information over again as we get from dashboards and reports, but it's about learning new things from data on the go, yeah, without the need to specify everything before even starting the analysis. Yeah, and I want to bring a few examples to make this a bit more concrete. Yeah, first example. Exploration can help you to spot root cause problems of things like asset failures, yeah, especially if the reason for these problems is unknown. Yeah, and you have to search the data like a needle in a haystack. Yeah, so this would be one example. Another example is it makes the data, let's say, the operation more transparent altogether. Yeah, so you see patterns that you were not maybe even aware of. Like this can be slow drifts, this can be subtle changes, yeah, that you wouldn't even spot in a Pi Vision dashboard, for example. This might be dependencies on ambient conditions and much more. Yeah, so kind of really deepen your knowledge about your own operation by means of the data. And third, I think that's also important. It's about learning about data quality problems. Yeah, I mean, I think most of you are aware that data quality is or actually should be a big issue, because if the data quality is bad, everything based on it is very likely to be wrong and misleading. This can be KPIs, reports, dashboard predictions, and so on. Yeah? All of that is, let's say, in the end, based on the data quality that you have on below. Yeah? It's simply this garbage in, garbage out principle. And data exploration is important to, let's say, assess this data quality. Yeah? And therefore, it should be an important early step in every data project. Yeah.
Actually, there's one quick thing I want to add to this data quality aspect, if I may share once more my screen. There is one little slide that actually fits very nicely to this data quality aspect. If you just trust some kind of numbers, let me very briefly open this up. It's a small example why actually this exploration really helps you. Now, if you look at these four pictures, you see four different data sets. Yeah, they clearly look very different. But we usually would ask you now, what do you think might these four data sets actually have in common? And actually they do have a lot in common. Yeah, these data sets, even if they look so different, have exactly the same mean value in both dimensions. They have exactly the same variance in both directions. They have the same correlation, and even if you model them with a regression, they would give you exactly the same formula. And the point of this is, if you only look at such numbers, and if the data quality is not considered visually, like here, for example, you might get out a result that's highly misleading, okay? And data exploration actually tells you very quickly that if the process should be like this, but it looks like this or like that something is actually wrong, that the numbers wouldn't tell you. Okay, I think I hope that this maybe was able also to clarify this a bit, what this aspect of this data quality might mean. So.
Okay, very good, very good. So like I mentioned earlier, there are a few more questions that are in the box, but in the interest of time, definitely we will be getting back to those who post those questions. At this point, I would like to give the floor to Harold on the call to action part. Definitely, we would like to hear more from you. And Harold has a suggestion where we can continue on the conversation, get deeper into how Calibrate and Visplore can help you. Harold?
Yeah, so thanks, Ted. So we hope that you saw, so to all of you attending, that you saw something where you say, okay, this is cool. Maybe we hope we could bring the point across how Visplore, let's say, adds additional value to what you might have already covered by, let's say, existing dashboards and so on. Yeah, and it really gives you a big return on investment digitalization investments by being able to faster troubleshooting and so on. Yeah. And now we are aware, of course, that whatever example we bring, typically the more convincing part is to see it on their own data. Yeah. And so therefore, one offer that we make is, if you want to challenge us a bit, please approach us. You can approach us via Calibrate, to make a common joint demo session. And if that's possible for you and feasible, just give us a few weeks or months of asset data, maybe with some failure that you have been, let's say, investigating in the past, and then we would show, based on that demo, how Visplore can help you to spot the root cause of this, or at least be able to identify in the data a bit earlier on when, for example, this asset failure could have already been detected. So this means challenge us with your own use cases. I think this can give additional, let's say, value to you, because maybe in the best case you learn something about your operations that you for free, that's an important point, because it doesn't cost you anything. So it means learning something about the operations. That's an offer I want to make. If this is too much, let's say, work for you, then of course, but you still would be interested to learn about Visplore, still, of course, you're very welcome to set up a joint call together with Calibrate and us, and then we can, let's say, go deeper into the discussion about your specific operation, about your specific assets, and of course could also deepen this part about your questions and about giving demos that come as close to your use cases as possible. Yeah.
Very good, very good.
The next step suggested.
Very good, and thank you very much, Harold, for articulating that. I believe that is a very good, very fair offer. I think what resonates to me is that it's for free. Okay, but
Yes.
I think this is something that we can really carry on the conversation. Definitely, the people attendees here have questions of what is this, what is that, and if I may say so, the proof of the pudding is in the eating. So let's have that. I mean, let's do that test, that challenge that our friends from Visplore are willing to take. So very much, and I hope everyone here would really think through. So before I close the session, maybe David would want to have a few more words. before we
No, yes,
part
just in
ways?
support of Aaron's and Thomas' offer, of course, Calibrate is your local partner here in the Philippines, Malaysia, Indonesia, in Southeast Asia. We're willing to do the work for you, create that value. We will support Visplore here in our region. Work with us, and we will mostly collaborate and work that value for your company. For me, thank you very much to everybody, and see you soon.
Thank you. Thank you. And on behalf of my colleagues in Calibrate and our friends in Explore, I thank you for you spending time, at least an hour with us, and hopefully you were able to gain valuable insights. And we actually look forward to having a much more deeper conversation with your requirements. Thank you all, and good afternoon.
Thank
Bye-bye.
you very much.
Thank
Thank
you.
you.
Thank
Thank
you.
you.